Now here this is medium 1 and medium 2. A ray of light is traveling from medium 1 to medium 2. It will bend like this, and this is I, this is R, and it is incident perpendicular on a mirror. Okay, this ray of light, because it is incident perpendicular, will travel back. Now, initially, we are talking about refractive index of second medium with respect to first. That is equal to sine I upon sine R. But if you follow the red arrows, you get refractive index of first medium with respect to second, because the ray is going from this medium into the other medium. In that case, this will be the angle of incidence. So sine of angle of incidence upon sine of angle of refraction. So now it's very simple observation. You can see that what we get is refractive index of second medium with respect to first is refractive 1 upon refractive index of first medium with respect to second. This is called as principle of reversibility. You can get easier questions like refractive index of glass with respect to water. If that is equal to 4/3 or something like say 8/7, then refractive index of water with respect to glass. Okay. Refractive index of a denser medium with respect to a rarer medium will be always greater than 1. And refractive index of rarer medium with respect to a denser medium will always be less than 1. That is how you can identify. How do you know that? Okay, so refractive index of denser with respect to rarer is velocity in the rarer medium upon velocity in denser medium. And we know that numerator is greater, so therefore it is greater than 1. And over here is velocity in denser upon velocity in rarer. The numerator is smaller, therefore that is less than 1. Of course, it is going to bend, so we make this dotted. Now this ray of light is bending, so therefore I'm drawing it over here. Okay, this is bending. Now what happens is at that point we are drawing another normal, and this ray of light. So this is angle of incidence. This is angle of refraction. This will be equal because they both are 90°, and these two are parallel. Okay. Now the ray that is coming out parallel to the dotted line. That means it is coming out parallel to the direction of the incident ray. So when you're drawing this diagram, you need to be careful about that. And here you need to show the 90°. So this is a 90, and that is called as lateral displacement. Okay, lateral means it is getting displaced sideways. That's why it is called as lateral displacement. And if I call this as D, so D will be more if I is more. Okay, D will be more. The refractive index is more. D will be more if the thickness is more. Now this is the thickness that I'm talking about. If you take a glass block which is more thicker, it will give you more lateral displacement. And of course, it inversely varies with the wavelength. So these are the factors on which the lateral displacement depends. So this will be air to glass. That's why it is bending towards the normal. And then it is glass to air. Therefore, it is bending away from the normal.